two astronauts ventured outside the International Space Station early Thursday to carry out what amounts to hand transplant surgery on the lab's Canadian-built robot arm, removing a crippled grapple fixture on one end of the arm, and replacing it with an onboard spare. Floating in the Quest airlock, Station Commander Randy Bresnik and Flight Engineer Mark Van de Hey switched their spacesuits to battery power at 8:05 a.m. EDT, GMT-4. To officially kick off US EVA 44, the first of 3 excursions planned over the next 2 weeks, to service the Canadarm2 space crane, and carry out a variety of maintenance work. "It's more gorgeous and heavenly than I saw when I was out here 8 years ago," Bresnik, a spacewalk veteran, marveled as he floated out of the airlock 250 miles above Africa. "Good morning, Egypt." A few moments later, Van de Hey, making his first spacewalk, made his way outside. "And Houston, that might have been one small step for a man, but one giant leap for Sabo," Bresnik said, using Van de Hey's nickname. "Congratulations, my friend, on becoming the 221st human to exit in your own personal spacecraft into the void of space." "Appreciate those words," Van de Hey replied. "Happy to be doing this with you." For identification, Bresnik, callsign EV1, is using helmet camera 18, and wearing a suit with red stripes. Van de Hey, EV2, is wearing an unmarked suit and is using helmet cam 20. The primary goal of the spacewalk is to replace latching end effector A, or LEA, one of 2 grappling mechanisms on the station's Canadian-built robot arm. One LEA typically is used to anchor the arm at various attachment points on the lab complex, while the LEA at the other end is used to lock onto and move visiting spacecraft or other large components. The arm also relays power, data and video to and from attached payloads. The LEA is the mechanism, the set of mechanisms, that does all the heavy lifting. It does all the mechanical attachment when the arm walks in over and establishes a new base point, when it picks up our robot Dexter to go do station maintenance, or when it catches and releases free-flying cargo vehicles, said Tim Braithwaite, the Canadian Space Agency station liaison. The Canadarm2 measures 57.7 feet long, weighs nearly 4,000 pounds, has 7 joints, and, in the weightless environment of low Earth orbit, can move large spacecraft and modules from one point to another. The LEAs feature internal snares that rotate and tighten to lock onto grapple fixtures, while latches engage to supply power, data and additional rigidity. Each LEA is a very complex package, Braithwaite said. "There are a lot of mechanisms, lots of onboard avionics, a camera, a force and moment sensor. It may be one of the most complex electromechanical packages that we've flown in space." The 2 identical LEA mechanisms allow the arm to move in inchworm fashion from one mounting point to another on the station's exterior. The arm also can mount itself atop a mobile transporter that runs on rails along the front side of the station's solar power truss, to move the arm to various work sites. In recent years, telemetry has indicated age-related degradation in the latching end effectors. Since these components are well beyond their design life, this really is expected wear and tear on the arm, Braithwaite said. It's been manifesting itself partly as increased motor currents in the mechanisms on board, and particularly the latches. On August 22, flight controllers at the Johnson Space Center in Houston were attempting to reposition the arm when the LEA latches failed to fully extend. "We actually had the latches stall during that operation, which is quite unusual," Braithwaite said. "We took a really good look at all the data, and basically, that LEA latch mechanism is telling us that it's time for repairs." With the robot arm positioned between them, Bresnik and Van de Hey will remove insulation and loosen 6 bolts holding LEA in place so it can be removed and temporarily mounted on a card attached to the arm's mobile transporter. The astronauts then will remove an operational LEA currently attached to the transporter itself and bolt it in place on the end of the arm, tightening the 6 bolts and reattaching the insulation. The faulty LEA will be repositioned on the mobile transporter, and eventually return to Earth for repairs. During one or more spacewalks early next year, the arm's LEA grappler will be removed and replaced with a spare currently mounted on an external storage platform. Another flight-ready spare is available for launch as needed. The arm was designed to last for the whole duration of the space station program, with maintenance, said Braithwaite. The life of the components, we used a 10-year figure. For some aspects of the design, we also used 15 years. Here at 16 years, for an item this complex, we're very pleased both leads lasted this long. In the near term, 2 more spacewalks are planned.